Hi, everyone. We're Ventrix Labs, and we're transforming buildings around the world into carbon capture hubs. Buildings contribute to 26% of the total greenhouse gas emissions, and 1/3 of that comes from direct emissions, such as on-site fossil fuel burning. And through speaking to 140 different buildings, we identified this unique problems where breweries are currently purchasing CO2 to carbonate their drinks, but they're emitting 2 to 3 times than they buy. At the same time, they have this cost problem where they could be paying anywhere from 300 pounds to 4,000 pounds per ton because they're not buying in bulk or they have this volatile supply chain problem. So Ventrix can offer a very compelling solution to cut this cost down to 1,300 pounds per ton today at 300 pounds at year 3. How do we do that? We're turning waste emissions into high-grade CO2. Our technology harvests waste energies within the building to power our ultra-low energy consumption carbon capture unit. After the carbon is captured, we either recycle it for food or medical-grade use, or we remove it by storing it underground or mineralizing it. And because of our technology, we can reach up to 90% more energy efficiency than our direct air capture competitors. And the V1 unit is for a recycling use case, and here we're offering 2.8 years of payback period as of today, and after we manufacture 200 units, we can reach 6 months. And that unit itself covers the entire total addressable market of the on-site CO2 supply for food and beverages, hospitals within the UK, US, and EU. And here, we can really help with SMEs that are paying too much for their CO2 consumption. And we're starting with the breweries in the UK first. How are we going to do that? We're going to slowly roll out our paid pilots within the next 18 months. We're going to start our direct sales to lead 70 units of sales by the end of 2028 before we transition to subscription-based sales. Here, we're going to ramp up our sales at 700 units by the end of 2030 before we reach a point to license our technology to gas providers or estate developers. This entire strategy yields over £1 million in profit by the end of year 3. And at scale, we want to build a decentralized carbon capture, utilization, and storage network where excess carbon captured can be used, reused, removed locally within the built environment. And this allows us to tap into the built environment ventilation systems where HVAC-based carbon capture can reach a 2 gigaton level impact within the built environment. Across vertical 1, for reuse, we're leading in compactness. This means low CapEx, which is the main barrier for entry for on-site CO2 recovery customers. And across vertical 2, for removal, we're leading in both size and energy efficiency. Just to recap, we're extremely energy efficient. We're modular, easy to use. We're providing price stability and low cost and a quick payback period. So far, we reached TRL level 5 in under 6 months since incorporation. We then went on to secure 7 on-site visits, 3 LOIs signed, and 2 supplier partnerships established. And our file's currently finished drafting and looking to be filed. Our patent has already finished drafting and looking to be filed alongside our trial next month ahead of our pilot and early rollouts. And we have a great team to do this. Together, we have 7 years of manufacturing experience, formal startup leadership experience, research expertise in carbon capture and mechanics, and our advisory board has decades of expertise in carbon capture, energy transition, and commercializing climate technologies. Today, we're inviting investors to join our decentralized net zero future. We're turning buildings into active climate solutions. And we're going to start with our pre-seed that's currently open of £800,000 to fund our trial, pilot, and the early rollouts, and closing by Q2 2025. This is Ventrix, and we're transforming buildings around the world into carbon capture hubs.
Well done. We'd now like to invite your team members to do the Q&A, and I'll ask you to all file in to the side if you can. Okay. While the questions come in, just a reminder, you can scan the QR code above me. Let me come on the other side of you so you'll have space. And you can put your questions, submit your questions via there. To kick things off, tell us about your IP strategy. What are you planning to defend first?
Yes, so that's a really good question. The crux of our IP lies into how we're integrating within the system. So to understand that, you kind of have to understand the landscape right now. A lot of carbon capture and direct air capture have invested heavily in industrial-sized machinery, so industrial-sized patents. And what we're significantly smaller, and that changes the mechanics of the system. So we can be up to 40 times smaller than them, which is insane. And we also have to take into account that we're integrated into a building, which changes the fluid mechanics of the system. So the solid mechanics and the fluid mechanics are different to industrial-sized DAC. And so that is the kind of crux of where our first patent will lie. We also, because we're so small, we can harvest not just external heat loss or excess resources, but also our own heat recovery systems. That's another point where that brings our energy efficiency down super, super low. And then going forward, we also hope to automate the entire process. Our dynamic control and current point source capture, carbon capture, has not been innovated on in a while. So that's also a differentiator within the market that we're in right now.
Okay. While those questions come in, yes, we do have one in. Talk to us about how you plan to scale to different markets.
Yeah, I can take that question. So currently, our unit can be used specifically within breweries or any sort of on-site CO2 recovery. So that mechanics itself is very adaptable to different sites. So we can move from breweries to wastewater and treatment plants very, very easily because the unit itself is pretty much the same. It's just the different flue gas or gas streams that are coming in that are different. So we just have to adapt to those. But I'll let Yuchen explain a bit more about that as well.
So for us, our units is winning in the first is a recovery rate, which is very important for the brewery market. Secondly, our unit can adapt to the different purity of the CO2, have a very wide range, lower down to the 15% up to the 99%. So that's allowed us to bolt on to the various markets like the wastewater treatment plant and other CO2 use case.
Okay, brilliant. Another question in from the audience asks what the main commercial uses are for CO2 other than breweries. How big is the market?
Yeah, so currently we are working with merchant CO2 market. So this mainly means that we're recycling CO2 for food or medical grade use and as well as industrial grade use. So this is including welding gas, hospital gas. So yeah, any sort of on-site CO2 reuse, that's what we can provide to. At scale, we can also embed the CO2 within cement to sequester that. So what we're planning to do is to build a decentralized network locally within the built environment so that the transportation cost for sequestering CO2 is extremely lower than some of our other competitors. So so we can sequester it within cement. We can inject it underground for cities that are closer to the coastline and near the injection slots. Yeah.
Okay. Moving on, what is the origin of CO2 captured?
So mainly currently we're looking at point source. So this is including brewery fermentation gas, as well as flue gas from gas boilers within the built environment, such as commercial buildings. But we also have the ability to do direct air capture, so where the origin will be from the air as well. So because this unit itself is sorbent agnostic, it's extremely versatile, and this is designed for that.
Okay, that brings us to time. Thank you very much, Team Ventrix.